Let's take a look at functions involving radicals. You've pretty well seen this before. We've seen functions before, and you've seen radicals before, so it kind of combines the two together. Let's first take a look at evaluating functions. First problem, we got f of x is equal to square root of x plus 4. And the first thing we want to find is f of 12. Well, remember with evaluating a function, we go through and where our variable was, we put in parentheses. Everything else remains exactly the same. Now whatever's inside the parentheses right here is what we put in right here. So put 12 in there. Well, 12 plus 4 is 16. And you should always simplify your radicals. 16 is 4 times 4. Now remember with a square root, we're looking for a pair of somethings. Here's a pair of 4s, so a pair of 4 is going to come out in front as a single 4. And since we took everything out of the radical, then it disappears. So our answer is just 4. Let's look at B. We got f of 8. Again, we're evaluating this function, so I'm going to go through, and where I have my x, I'll put in parentheses. Everything else remains exactly the same. Now whatever's inside the parentheses right here is automatically we're going to put in right here. So we'll put an 8 in there. Well, 8 plus 4 is 12. And always you should simplify your radicals. So 12 is 2 times 2 times 3. Remember with square roots we're looking for a pair of somethings. Well, here's a pair of 2's. So this pair of 2's is going to come out in front as a single 2. And we're left with a 3 inside the square root, so our answer is 2 square root of 3. You can only bring something out if you have a pair of them. We only have one 3. Let's take a look at f of negative 3. Again, we're going to go through, and we'll put parentheses where x is. So we've got square root of parentheses plus 4. Whatever's inside the parentheses right here is automatically what we'll put in right here. So we'll put in negative 3. Well, negative 3 plus 4 is 1, and square root of 1 would give us 1. I didn't write it out, but 1 is 1 times 1, and again we got a pair of 1s. We're looking for a pair of somethings. Let's look at our second problem. We got, get my glasses on here. H of x is equal to cube root of x minus 3 over x minus 2. And we want to find h of 4. Again, we're going to go through and we'll put parentheses where x was. So we're going to have the cube root of parentheses minus 3 over parentheses minus 2. Now whatever's inside the parentheses right here is automatically we'll put inside the parentheses over here. So we'll put a 4 here and 4 here. So we're going to have the cube root. 4 minus 3 is 1. 4 minus 2 is 2. Now remember on our simplifying, when you got fractions and radicals, you got two basic ideas on them. You can't have a radical in your denominator. You cannot have a fraction inside of your radical. Well, we got a fraction inside of a radical. So we can split this up. We can put a radical right on top. So we got the cube root of 1 over the cube root of 2. Well, we got rid of the fraction inside the radical, but we put a radical in the denominator, which we can't have. In the beginning, and before we look at that, cube root of 1 is 1. Cube root, square root, whatever radical you have, if you have a 1 in there, it always just gives you 1. Then down below, we're going to have the cube root of 2. Okay, now we can't have radicals in your denominator. So this is a cube root. Our index is 3, the number in the slot. That tells you how many you need. We got 1, 2. That means we need 2 more 2's. Because we need a total of 3 2's. Now whatever you multiply by the bottom, you have to multiply by the top. So multiply the top part by the same thing. Now the index will tell you exactly how many 2's you need. If this was index was 4, I'd need 4 of them total. If it's 5, I'd need 5 2's down here. Well, up on top, the 1 doesn't do anything, but I got the cube root. 2 times 2 is 4. And down below, since we got our index is 3, we got 3 2's, that just gives us a single 2. And that's our answer. Now B is h of 7. So we got the cube root. And again, we're going to go through, and wherever we have an x, we'll put in parentheses. So we got parentheses minus 3 over parentheses minus 2. Whatever number you have inside the parentheses right here is automatically put inside these parentheses. So I'll put a 7 here and 7 here. Well, we got the cube root. 7 minus 3 is 4. And 7 minus 2 is 5. Again, we got a problem. We got a fraction inside of radical, so we don't want that. So we'll split it up. Put a radical around top. So I got the cube root of 4. And we'll put a radical around the bottom. So we got the cube root of 5. Okay. Now the issue is the radical and denominator. We can't have that. So let me go ahead and write this down again. We got the cube root of 4 over the cube root of 5. Our index, the number in a slot, is 3, which means we need 3 5's. We only got 1 5. So I'm going to put 2 more 5's down here. And whatever you multiply by the bottom, you have to multiply by the top. So put 2 5's inside the cube root up there, too. Okay. Well, up on top, multiplying these together, 5 times 5 is 25, times 4 is 100. So we'll have the cube root of 100 over, now on the bottom we got index is 3, we got 3 5's. So that just gives us a single 5. And that's our answer. Okay, part C. We got h of negative 2. Now again, we're going to go through, and everywhere we have a variable, we'll put in parentheses. So we've got parentheses minus 3 over parentheses minus 2. Whatever number we have inside the parentheses right here is automatically we'll put in right here and right here. So we'll put a negative 2 in there and negative 2 in there. So the cube root. Negative 2 minus 3 is negative 5. And down below we got negative 2 and negative 2 is negative 4. Now negative divided by negative is positive, so this becomes 5/4. And we're back to the same issue as the first two parts. You cannot have a fraction inside of a radical. So we'll split this up. I'll put a cube root around the top. And I'll put the cube root around the bottom. Now to begin with, on the bottom we have 4. Well, 4 is 2 times 2. Okay. Now the issue is we can't have a radical in the denominator. Our index is 3, means we need 3 of whatever. We got 2 2's, so I just need 1 more 2 down there. Because I need 3 of them. And then whatever you multiply by the bottom, you have to multiply by the top. Okay, so up on top, I got 5 times 2 is 10, so we got the cube root of 10. And down below, our index is 3, we got 3 2's, so that gives us a single 2. And that's our answer. And let me start a new page. And let me bring up Word. Because we're getting ready to talk about domain. And I want to type what we're going to be taking a look at. Okay, now we're going to have 2 different types here. See, this says find the domain of the radical function. We got the square root, 5x minus 2. This one says find the domain of the radical function. We get the fifth root of 7x minus 1. Now what we're going to be looking at specifically is a number in this slot. That's called our index. In this problem, index is 5. And on this problem, it's a square root, so our index will be 2. So we have two different cases. We have one where the index is even and one where the index is odd. So let's take a look at the index is even. Okay, so finding domain of a radical with an even index. This is the harder one. The other one's a lot easier. So to find the domain of that, what we do is we set what is under the radical greater than or equal to 0 and solve. So set what is under the radical greater than or equal to 0 and solve. So we got g of x is equal to square root of 5x minus 2. Again, square root, a number in this slot here, there is no number, so this is by default 2, which is even. And our instructions say set what is under the radical, which is the 5x minus 2, greater than or equal to 0, and solve. So I take the negative 2 over the right side, becomes a positive 2. I'm going to divide both sides by 5. And we got x is greater than or equal to 2/5. And that'd be our answer. If you want to write it in interval notation, you can. It would look like this. We'd have a bracket because it's less than or equal to. The line underneath tells us the bracket. Then 2/5, comma, positive infinity. I'm happy with this answer that I circled. But now the second one. Looks like this. We got h of x is equal to fifth root of 7x minus 1. This is a radical with an odd index. So, finding the domain of a radical with an odd index. And your answer is all real numbers. So pretty easy. On this one, the easiest way to write all real numbers is negative infinity, positive infinity. Or you could just simply write all real numbers if you want. So the domain problems with a odd index are very simple. You don't have to do any work at all. Now this next one's kind of an oddball case, and we're going to think through the answer. We actually haven't covered enough. You don't cover it until college algebra. We haven't covered enough to actually solve it with algebraic techniques. So let's see. We got f of x is equal to square root of 5 over x plus 2. Okay, now this is an even index. It's a square root. So our instructions say set it greater than or equal to 0 and solve. Well, that'd be a good start. 5 over x plus 2 is greater than or equal to 0. Okay, well, let's talk about this. Greater than 0, that means positive. And the top part is 5, which is already positive. If the bottom part was negative, then we'd have a positive over negative, which is negative. And we don't want that, because we want it greater than 0. Okay, well, if this is positive, the bottom part is positive, then I have positive over positive, which gives you something greater than 0. So this one can actually become x plus 2 is greater than or equal to 0. We'll come back to that. We have to tweak that a little bit, but let's go ahead and solve that. Take 2 over, and we got x is greater than or equal to negative 2. Well, think about what would happen if it's equal to negative 2. If I put negative 2 up here, we'd have negative 2 plus 2, which gives us 0. We'd have a 0 in denominator. So this becomes x is greater than negative 2. Can't be equal to it. Now the question becomes, is there any value we could put in here that causes it to equal 0? And there isn't. Because the only way you can get a 0 when you have a single fraction is you have 0 divided by something, not 5 divided by something. So our answer would be x is greater than -2. If you like interval notation, I put parentheses, -2, comma, infinity. Since there's no line underneath the greater than, that's why we don't put a bracket. We just put a parentheses. Now the last two are graphing ones. So let's take a look at this. First thing, let's talk about the domain. It's a radical with an even index, so we're going to take what's inside of a radical, set it greater than or equal to 0, and solve. So we got x is greater than or equal to 2. And that would be our domain. Okay, then they say to graph it, so let's do that. I'll press my y equals, press my clear. I want square root, so I do second x squared, and then x minus 2, and graph. So our graph for this particular one will look like that right there. Okay, they're also asking us to find our range. Our range is our y values where a graph exists. If I come down here, for example, at y is equal to -1, if I go left or right, I don't find my graph anywhere. The lowest point on my graph is right here, which is y is equal to 0. So 0, and then you see it's going up. So my range, if I wanted to put it there, I could say y is greater than or equal to 0. Now again, you do not have to write these in this form. You know, your range here, you could just put bracket 0, comma, infinity, like that. Or your domain, you could put bracket 2, comma, infinity. Bracket because of the equal to part on here, the line underneath your inequality symbol. Okay, and our last one, we got g of x is equal to the cube root of x plus 1. Okay, to begin with our domain. It's a radical with an odd index, which means our domain is -infinity, +infinity. We can plug any values into there. Okay, let's look at the graph. Press my y equals, press my clear, cube root. I go to my math, and that's where I find my cube root. So I press 4, the number in front of it, or you can down arrow to it and press enter on it. If I simply press 4. And then we want x plus 1. And you can put a closing parentheses if you want, then graph. Closing parentheses on a TA3, TA4 is optional. Our graph looks something like that. I don't draw it real well. Now our range, our y values where our graph exists. Well, if I look at this, it might be easier to see. See how as it's going to the right, it's slowly inching up. So it'll keep slowly inching up forever until it goes to positive infinity. As this goes to the left, you see it's slowly inching down. It'll keep slowly inching down forever, so it's going to negative infinity. So our range here will be negative infinity to positive infinity. Same as the domain. To be honest, I don't know if you find a radical with an odd index that doesn't have the domain and the range as negative infinity, positive infinity. You might. I just can't think of a particular example right now. And that would be looking at our graphs of radicals.